Look closely at this gemstone. Its blue is so intense it looks like it's holding its own electrical charge. This is the Paraiba Tourmaline, a crystal so rare it can easily outvalue a flawless diamond. But what mainstream science doesn't tell you is that the birth of this impossible color solves one of Earth's greatest riddles. It is a molecular clue that proves what we are taught about plate tectonics is incomplete. As observers of reality, we must question school textbooks. They claim that tectonic plates move on their own to split continents and push up mountains. But think logically. The continental and oceanic crusts are not engines. They are, in fact, a massive waterproofing and thermal insulation barrier. Their function is to regulate heat and shield the planet's internal thermostat. They prevent oceans from flooding the furnace below and keep the deep heat locked in. The plates are a passive shell. The true engine comes from deep within the Earth's belly. Around 250 million years ago, the world was unified as Pangea. Underneath that thick thermal blanket, heat accumulated to an extreme. And when Earth's internal furnace needs to release energy, it creates mantle plumes. Colossal thermal blowtorches that rise vertically with brutal force. These plumes rip the protective insulation apart. They are the ones that actually split continents, driving the hardest rock shields on Earth, the Cratons. As the mantle plume tore through the boundary between what is now northeast Brazil and Africa, a process of extreme physical distillation began. The heavy magma, loaded with iron and magnesium, froze first at the base. This created the dark basaltic rocks that would later weather into the rich red soil behind Brazil's coffee empires. But the lighter, rejected chemical elements were squeezed upward into the highest fractures at the Craton margin. There, trapped in deep veins called pegmatites, a leftover fluid rich in superheated water, boron, and lithium became isolated, cooling in slow motion over thousands of years. In crystal physics, slow cooling gives atoms time to align into flawless geometric networks. The structure of the tourmaline was being born. But here lies the dead end of chemical logic. For a tourmaline to turn neon blue, it absolutely needs copper. The problem is, copper and tourmaline forming elements run in completely separate paths in the crust. They almost never cross. It was a statistical mathematical anomaly. In this deep fracture zone, the residual fluid essentially washed the surrounding rock and stole its copper. And the engineering of continental separation was highly specific. When the ocean finally ripped Pangea apart, the side that became Africa ended up with much larger deposits, but contaminated with heavy manganese, creating greenish or violet stones. The corner that stayed in northeast Brazil, however, hit the perfect ratio: high copper and almost zero impurities. The pure, concentrated extract of the cleanest neon blue on Earth. Tectonic plates control Earth's thermal insulation, but it is the vertical force of mantle plumes and the geometric resistance at the Craton margins that shape our landscapes and extract our wealth. Gold, iron, diamonds, and the Paraiba Tourmaline do not surface by chance. They are the product of a monumental hydraulic press that used the indestructible shield of the Craton to squeeze, filter, and distill the purest chemistry from Earth's core. When we look at this gemstone, we aren't just looking at a pretty rock. We are observing the physical signature of the birth of our continents.